So this is the second period video. We'll be doing the evens in this. And so you guys that are in second period right now, I'll record the odds during fourth period and post that video. So as you're working through or checking, you could check that video if you wanted to see any of the odd answers. Okay, table question, and you kind of glance through the quotient rule, product rule, chain rule. We're doing the even. So number 2, f times g. The derivative of f times g would be fg prime plus gf prime. And then all of that at 6. So rather than write parentheses 6 4 times, I'll just say at 6. So f at 6 is negative 5. G prime at 6 is negative e. And that's good. I see some 5 e's there, so I'm probably on the right track. G at 6, so g when x is 6 is negative 7. And f prime at 6 is pi. So 5e minus 7 pi. 5e minus 7 pi, that's answer choice D. So that was just purely testing the, mostly testing the product rule, but also can you look at a table and find the values that you need. Number 4, h prime of 3 if h of x equals g of 2x. So this looks like a chain rule thing here. So outside in, derivative of g is g prime. Leave the inside alone. And my guess is that's probably the majority of the mistakes are people doing that, g prime of 2x. What am I missing? What else do I need to include on that? Times 2, the derivative of 2x. So the chain rule. And so I'm going to guess without even doing this, given that the times 2 is probably what's left off, I'm going to guess that A is my answer. Well, let's see if that's right or not, since negative e and negative 2e were both there. So I want g prime of 2 times 3 times 2. So g prime of 6, g prime of 6, did that one already. G prime of 6 is negative e, times 2 is negative 2e. But again, that 2 from the chain rule is what people will forget. Must there be a value between x equals 2 and x equals 9 where f of x equals 0? Between, that's kind of a flashing red light that what's going on here. What kind of problem is this? That's an IVT. It's probably an intermediate value theorem. So I need to check f of 2 and f of 9, and it asks if. It doesn't say show, so must there be? It's a question. So I'll be looking to see if 0 is in between those two values. Let's see, f of 2, I'm looking up at the table still. F of 2 is 3. F of 9 is negative 4. And I can't make the conclusion yet because the first part of IVT that I sort of left off, I have to say that f of x is continuous. I knew that. If f is differentiable, differentiability implies continuity. You can't be differentiable without being continuous. So I would need these two statements to get my full answer correct. F is continuous. The reason I know that is because they told me that it was differentiable. Okay, so 0 is in between f of 9 and f of 2. Therefore, so the y value is in between the y values. Therefore, 0, or x, is between the x values. Is between x equals 2 and x equals 9 for f of x equals 0. I worded that a little bit weird. F of x equals 0 somewhere between 2 and 9. Maybe that was a better way to say that. IVT is continuous, and then y is intermediate, therefore x is intermediate. Like, there's your 3 basic steps for IVT. The function is continuous, the y value is in the middle, therefore the x value is in the middle. Number 8. Picture problem. The graph of G consists of 2 line segments. F is given by G of x. So already I'm thinking chain rule. I don't even know what's coming, but that looks like a chain rule thing. What is the value of f prime of 0.5? Well, f prime, that would be G prime of G of x, chain rule, times G prime of x. Outside in, one layer at a time, multiply the derivatives, multiply the chain links. So f prime of 0.5 is G prime of G of 0.5 times G prime of 0.5. And I know it feels tedious to write all these steps, but man, when you start skipping these things, then you end up doing too much in your head and losing track of where you're at. All right, G of 0.5. G of 0.5 is 4. So that's nice. They gave me an easy spot to deal with. G prime of 4 times G prime of 0.5. G prime of 0.5 would be this slope. Let's see, we would go up 6 and over 3. So that's a slope of 2. But I also need G prime of 4. So that slope is, let's see, down 5 and over 5. So that slope's -1. So -1 times 2 is -2. So a chain rule question with a picture to go with it. Number 10. Ooh, goodness, that looks like natural log, looks like product rule, looks like quotient rule. Although I think I can get out of the quotient rule. Right? I can change this to natural log x to the 1/3 minus natural log e to the x. It's just algebra. That's not calculus yet. See how many things can I do at once here. The 1/3 can come down front. So 1/3 x natural log x, and I'm distributing the x. The x can come down front, and then times the x out front, minus x squared. So again, I still haven't done any calculus. That's all algebra stuff in an effort to make my calculus a little bit easier. I'm still going to have the product rule. So in my mind, there's how I'm splitting that up. So the first one is 1/3 x. The derivative of the second one is 1 over x. Plus the other way around, the derivative of 1/3 x is 1/3. Is a natural log of x. And then don't forget, sometimes people get so involved in the product rule that they forget that, hey, there's another term out here whose derivative is minus 2x. Let's clean that up a little bit. Those x's cancel, so 1/3 plus 1/3 natural log x minus 2x. Now that doesn't look exactly like any of my answer choices, but I definitely don't have any of this. That looks crazy. B's not right. C's got a natural log x over 3, so but the minus 2/3 isn't there. A looks funny, but they factored out the 1/3. That's where we get the 1 and the natural log x. And 1/3 of 6 is 2, so that's maybe a weird thing to factor out, but answer A is the right answer. That had like 3 algebra steps at the beginning, and then a couple of calculus things, and then another algebra step at the end. Number 12. Instantaneous rate of change. Fancy talk for derivative. So h prime of x. 3 is just there for follow along for the ride. Derivative of 2 to the negative x squared is 2 to the negative x squared. Chain rule. Negative 2x. And then I bet, is that even an answer choice? It's not an answer choice. They got to multiply by natural log 2. So which one of those things matches all of that stuff? Can't multiply that by anything, so those two can make negative 6x. 2 to the negative x squared, natural log 2. There it is. What's up? Because my base, this was similar to the warm-up we did. If the base isn't e, then you have to adjust for that. And so if it's an exponent problem, you multiply by the natural log of the base. If it's a log problem, you divide by the natural log of the base. On that warm-up, wherever it went. On the warm-up, the log was base 7. That's where we divided by natural log 7. On this problem, it was an e or an exponent problem, so we multiplied by natural log of 2. Number 14. G prime, if G equals all of that, so this looks like a product rule problem. So first times derivative of the second, derivative of cosecant. Oof. Secant goes to secant tangent. So it goes to negative cosecant cotangent. So negative cosecant of 2x, cotangent of 2x. And then the other way around. So the derivative of e to the negative x is e to the negative x times negative. And then we just leave cosecant of 2x alone. And of course that doesn't look like any of my answers. It looks like they factored out, all of them have e to the negative x factored out. Let's take that out. And a negative factored out. And a cosecant of 2x factored out. So if we take out all of that stuff, negative e to the negative x, cosecant of 2x, then what's left is cotangent of 2x plus, we took all of it, so plus 1 to kind of hold the spot there. So 1 plus, I messed something up, I think. Looking at my answer choices. Some of them have a 2 in there, and I don't. So did I mess that up? I think I needed, when I took the derivative of cosecant 2x, I took the derivative of cosecant, but I forgot about the derivative of 2. So, like a chain rule situation, there needs to be a 2 in there somewhere. Probably right there. So that 2 can go right there. So 1 plus 2. If that wasn't a multiple choice question, I would have missed that. But when I looked at all of my answers and saw the 2 there, I knew something was up. I needed to figure out whether it needed to be there or not. So again, that's like test taking strategies. Like once you get your answer, see if it's there, but maybe peek at the others and see if something triggers you, like, wait a minute, should mine have that in there? Like that might have happened on number 12, then ask where'd the natural log come from. Well, all of the answer choices had natural log too, so hopefully he would have remembered what was going on there. 16. Table problem. Selected values, blah, blah, blah. Equation of line tangent to the graph, so I need a point and a slope for G inverse. Okay, so this is an inverse problem. So G inverse, point, slope. Again, it takes a little bit of time to set up the problem, but well worth it in the end. And at the end, we'll get a reciprocal. Sort of the whole point of that reciprocal, or that inverse lesson, is reciprocals. Okay, x is negative 2 for the inverse. That goes there. You get the hang of these. They all kind of work the same, which means negative 2 goes there. So if negative 2 is the y value for G, what would the x value have been? Negative 2 is the G value. Yeah, that would have been 5. G prime at 5. I'll go ahead and put E. And then the reciprocal would be 1 over E. And so my point is negative 2, 5. My slope is 1 over E. So y minus 5 equals 1 over E x plus 2. Y minus 5, 1 over E x plus 2. And again, you can kind of see where the mistakes were made. Choice B, they didn't flip the E. It looks like some of the others, they got the 2 and the 5 backwards. Number 18. H of x equals that thing. H of 2 equals 7. Find the inverse. Oh, another derivative of the inverse problem. So H inverse, point, and slope. Let's get everything set up. Again, the main thing is the reciprocal. The derivatives are reciprocals. And what we want is the derivative of the inverse of H at 7. So that means my y value is 7. H of 2 is 7. Okay, so 2, 7 is the H point, which means 7, 2 is the inverse point. And if I can find the derivative of H, I can flip it over and get the derivative that I want. Well, this isn't a table problem, but they give me an equation. 3x squared minus 2. What am I going to plug in for x? 2 or 7? 2. Because I'm working on this top line here. H prime at 2. 3 times 2 squared minus 2. 4 times 3, 12. Minus 2 is 10. So the derivative of H at 2 is 10, which means if I flip all the x's and y's, the derivative I'm looking for is 1/10. And let's make sure we are indicating that that's our answer. That's one of those problems where it's easy to do everything, but if you don't label things correctly, I don't know that you know that 1/10 is the answer that we've asked for. Number 20. Let f be the function given by, what is the value of f prime of 0? Oh, that's a straightforward one. Nothing crazy about that. Derivative cosine is negative sine. And derivative of e to the x is e to the x. Yeah, wasn't expecting a problem of this difficulty to be number 20. Sine of 0 is 0. E to the 0 is 1. So, C. Doubting myself. It felt too easy. Derivative of f. Plug in 0. We like that one. 22. Oh, second derivative. Okay, again, there's no magic to landing on the second derivative. You can't skip over the first derivative and get to the second derivative. There's no magic formula to do that. You just have to find y prime first, and then do another derivative to get the second derivative. So first derivative, not too bad, chain rule. What are we going to have to use to get the second derivative? Product rule. Knowing that, which one of the... I think I can throw out two of the answers already. I think. If I'm going to have to use product rule, I'm going to end up with something plus something, so I'm pretty suspicious of A and B. I guess maybe if they end up being like terms, but I'm leaning towards C or D here. So second derivative would be first times derivative of the second plus second times derivative of the first so let's see here. I have to factor out e to the x cubed. Both of them did that. That would leave 6x plus 9x to the fourth. Answer choice D. Number 24. The slope of the line tangent to the graph. Slope of the line tangent to the graph. So the derivative when x is negative 1. So I need f or y prime at negative 1. So let's find y prime first. So that's 1 over 1 minus x. Oh, I bet some people stop there and their answer is 1/2. Why is that not the derivative? I forgot it. I forgot the chain rule earlier, but not this time. The derivative of 1 minus x is negative 1. So if I plug in negative 1, I got negative 1 over 1 minus negative 1, negative 1/2. Slope of the line tangent to the graph. So yes, I needed the derivative when x is negative 1. So yeah, C would have been forgetting the chain rule would give you C. D would be not taking a derivative at all. I don't know where the others would come from. Okay, so that's the evens. Hopefully you did the odds yesterday, so between the two of them, you got it all figured out. So looking at the test, there's 25 multiple choice. Those will be 3 each. There's a 4-part free response question. 4 points each, so that's 16. So I'll give you a free 9 points. Right, you miss everything, you still make a 9. Plus the 5-point AP classroom bonus, or potential bonus anyway. And I was trying to categorize the problem, so I'll just show this. Like while I was making the key, I was just kind of keeping hash marks, and that may not add up to the total number of problems because, as you know, lots of problems have like multiple things going on. So I was trying to tally like what's the most important part. So there were definitely some graphs, obviously some logs, a lot of exponents, not a lot of inverses, which means I probably didn't do a good job writing the test because there probably need to be more of those. And then I started to keep track of product, quotient, and chain, but like that happens so often, I gave up trying to keep track of that. Review questions, 5 or 6 of those. So that, again, I don't know what that adds up to. I was just trying to keep a rough count. There's definitely review questions. If you're confused by the inverses, which it didn't seem like you were, you'd probably be okay, but there are a few of them on there. All right, so hopefully that's enough.
We can with Calc, right?
Yeah, definitely with 25 of them, we'll have an iHeart Calc option with the +3 if you're feeling good about things. Yeah, so you can skip one if you like, or you can go for it if you're feeling good. Again, most of you try them all and then go back and pick one that you couldn't figure out, or go for it, whatever you like. Tutoring is today during B lunch, so if you're still struggling with something, by all means come see me and we can look at it some more.